People lie. It's a fundamental truth of the universe. Taxes exist. Water is wet. And people will absolutely lie about eating your sandwich. But here's the beautiful thing about electronics. Electricity doesn't lie. It can't. It just flows or it doesn't. And today, we're building a machine that uses that truth to expose human lies. We're building a Galvanic Skin Response sensor, a lie detector. When someone gets nervous, an LED lights up. When they're calm, it stays dark. It's not perfect, but it's incredibly fun at parties. That's right, you're about to become part of the circuit. Let's build this thing. Your skin is actually a pretty good insulator when it's dry. The dead cells on the surface create a barrier that electrons struggle to cross. We're talking resistance in the megaohms, millions of ohms. But when you get nervous, when you lie, when you're scared, when someone asks if you've been flossing, your sympathetic nervous system kicks in. Fight or flight. Your body thinks you're in danger, and one of the things your body does when it panics, it sweats. Your pores open up like tiny floodgates and release moisture. Now here's the chemistry magic. Sweat isn't just water, it's salty water. And salt, sodium chloride, conducts electricity really well because it breaks down into ions. So suddenly, that mega-ohm barrier drops to maybe 100,000 ohms. Still high, but way lower than before. The electrons can suddenly find a path. More nervous, more sweat, lower resistance, more current. We just need to detect that tiny change in current and amplify it until it's big enough to light an LED. And that's where our old friend the transistor comes back. Except this time, one isn't enough. We need two. The problem with skin current is it's tiny. We're talking microamps, millionths of an amp. A single transistor can amplify that maybe 100 times. But that's still not enough to light an LED. So we use a trick called a Darlington pair. It's two NPN transistors connected back to back. The output of transistor A feeds directly into the base of transistor B. Here's the beauty. Transistor A takes your tiny skin current and amplifies it by 100. Let's say you have 0.01 milliamps going in. It outputs 1 milliamp. But that 1 milliamp output doesn't go to the LED. It goes into the base of transistor B, which also amplifies by 100. So now you've got 1 milliamp times 100 equals 100 milliamps. That's 100 times 100, a total gain of 10,000. You've turned a whisper into a scream, a single drop into a waterfall. This is power. This is enough to drive an LED, enough to detect the slight change in your skin resistance when you lie about who finished the ice cream. Alright, let's build this thing. You'll need a breadboard, a 9-volt battery, 2 NPN transistors, a resistor, an LED, and 2 wires for the touchpads. First, the power. Battery positive goes to the red power rail. Battery negative goes to blue ground rail. This is old hat by now. Next, the LED and its bodyguard, the resistor. Remember video 2? LEDs have zero survival instinct. The resistor is non-negotiable. Connect the resistor from the positive rail to an empty row, let's say row 10. The LED's long leg goes in the same row. The short leg goes to ground. Simple. Now, the Darlington pair. Plug transistor A into the breadboard straddling the center gap. Collector on one side, emitter on the other. Base in its own row. Transistor B goes right next to it. But here's the connection. Transistor A's emitter connects to transistor B's base. They're piggybacking. Connect transistor B's collector to that row with the resistor and LED. Connect transistor B's emitter to ground. This completes the amplification chain. Finally, the touch pads. 2 loose wires, one goes to positive voltage, the other connects to transistor A's base. These are what you touch. That's it. That's the circuit. When you touch both wires with your fingers, your skin completes the circuit with a variable resistance. The Darlington pair amplifies whatever tiny current flows, and the LED responds. Time for the test. I'm going to hold both wires between my fingers. When I'm calm, the LED should stay off or very dim. Now I'm going to think about something stressful, something that makes my palms sweat. Let's say taxes. Okay, now let me think about something really stressful, like having to make small talk at a party, or calling the dentist. Or there it is, the LED flares up. My skin resistance dropped. The circuit knows I'm panicking. This is working. You can adjust sensitivity by changing the resistor value. Higher resistance, less sensitive, lower resistance. It triggers from breathing too loud. Now you have a machine that reacts to your biology. You've bridged the gap between flesh and electricity. You're a biohacker. 10 videos ago, you didn't know what voltage was. You thought current was something in the ocean. You were terrified of the magic smoke. But now you understand the Holy Trinity. You know Ohm's law. You can read a resistor's color code, even if it is stupid. You've tamed the suicidal LED. You've survived the capacitor's grudges. You've commanded the tiny tyrant transistor. You've mastered the breadboard. You've wielded the multimeter, and now you've built a circuit that uses your own body as a component. You're not a beginner anymore. You're not guessing. You're not just hoping things work. You're an electronics wizard. You control the invisible force. You bend electrons to your will. You can build things that react to the world. That's real magic. So go out there and build something. Make an LED blink in Morse code. Build a light-sensing circuit. Make a motor spin. Just please don't burn down your house. And if you see the magic smoke, don't panic. It just means you've learned something. Every dead component is a lesson earned. This is the end of the basics, but it's the beginning of everything else. Now go make something weird. Thanks for learning with us. Stay curious, stay safe, and remember, always check your polarity.